Next, we will talk about the limits and continuity because these are the basic before we could go to the topics about the tangent. So when we talk about the limits, if we want to find a limit for a vector value function, with this vector value function it has three components ft, gt, and ht, then the limits of this vector value function, to find this limit, we just need to find the limit for each of the components using the same approach. Now, for example, let's say if we are looking for the limit of rt when t approaches to pi over 4, where rt is cos t, sin t, and t, then what we need to do is to look for the limit for cos t, sin t, and t when t approaches to pi over 4. So we could see from here that the limit of cos t is square root of 2 over 2. The limit of sin t is square root of 2 over 2 as well. Whereas the limit of t, well, it is pi over 4. That will give us the answer that the limit of rt is equals to square root of 2 over 2, square root of 2 over 2, pi over 4. Another example that we can see here, it says find the limit of rt if rt it is t squared, t cubed minus 1, and t minus 1 over t plus 1 when t approaches to 2. So let's see. We look for the limit for each of the components. That gives us the limit of t squared is 4, the limit of t cubed minus 1 is 7, and the limit of t minus 1 over t plus 1 over 1 over 3. These are some very simple expressions that you can find the limit directly, and therefore the limit for the vector value function will be 4, 7, 1/3. Okay, now let's talk about continuity. We say a vector value function, it is continuous at one particular point t equals to t0 if the limit of rt when t approaches to t0 is equals to rt0. And we say the function is continuous if it is continuous at every point in its domain. Now geometrically, it means if you are able to sketch a curve without lifting your pen within the domain, then it is continuous throughout the domain. That's what it means. Next, talking about differentiability, because we want to know whether we can differentiate a function or not. Well, here it says a vector value function rt, which is fti plus gtj plus htk, has a derivative, or we say it is differentiable at t if f, g, and h, all of the components here, they have derivatives at t. In other words, r prime t or dr dt, well, this is the definition. And to find this dr dt, we just need to look for the differentiation for each of the component. Well, let's take a look here. Here, graphically, how do we know it is differentiable? You just need to identify whether there is any sharp corner. So from the curve, well, we can see these are a combination of 5 curves. Okay, we can say that these curves C1, C2, C3, C4, and C5, they are all differentiable. They are all smooth. But there is a sharp point between C1, at the intersection between C1 and C2. Okay, and there are other 3 more intersection points, which these points are sharp corner. At the sharp corner, we can't differentiate. We are unable to differentiate. So this is what it means by differentiability.